Now we're going to take a look at the binomial model, which is actually very similar. It's taking the geometric model another step. So if we're going to go ahead and have that speckled M&M's promotion, what is the probability that one of the first three candies is speckled? Well, your instinct probably is to say, okay, the first two candies are not speckled, but the third one is. So if you did that, you multiplied it out, you get 0.147 as the probability. Well, that doesn't quite take into account all the different ways that you can get the speckled candy. What you calculated was not speckled, and speckled. There's more than one way to get one speckled candy. You could also do not speckled, speckled, not speckled, that gets you 1, or speckled, not, and that gets you 1. Since each outcome is independent, each of the paths, if I were to multiply all these probabilities, I'm going to get the same answer for each path. So what I can do is take the number of paths and multiply it by the probability for that path. So 3 times 0.147, the actual probability of getting one speckled candy out of 3 is 0.441, or 441 10,000ths, or thousandths, sorry. So let's take a look at flipping a coin 4 times. What is the probability of getting 2 heads there? Do you think it's as simple as just going 4 times the probability? Well, first of all, let's go ahead and do probability of heads and heads, then tails and tails. So probability of 2 heads in a row is 0.5 squared, and then another 2 tails is 0.5 squared. I get 0.0625. And if we check it, if I do this huge sample tree right here, you can see, okay, heads, heads, tails, there it is. That's one path to get 2 heads. But there's also this one, and this one, that one, and finally that one. So there's 6 different paths. So if I wanted to calculate the probability, I've got to take this number and multiply it by 6, which basically gets me 375 thousandths, or basically 3/8. Is there a faster method to count 6 ways to get 2 out of 4? Because let's say I want to do probability, flip a coin 10 times and get 7 heads. I really don't want to make a tree for 10 choices. Here you can see there are 16 different outcomes. Where does that come from? 2 choices here, times 2 here, times 2 here, times 2 here. 2 times 2 times 2 times 2 is 16. If I did it to the 10th, then that would be 1,024, and I really don't feel like drawing trees with 1,024 branches. Luckily, there's an easy way to count the number of combinations, and there is a formula. It can be written like this, n over k, so it's really n choose k. N is the number of ways to, there's k successes and n Bernoulli trials, and C stands for combinations. It's often also called n choose k. So you have n trials and you're going to choose k to be successes. So to calculate the number of combinations, we use this formula right here, which if you've ever seen factorials before, you might have seen this. We are teaching this formula in geometry now, but it hasn't really been taught before the last year or two. So what is this exclamation mark? Does it mean that you have to say n extra loud? No, it means n is a factorial. So you basically multiply every integer up through n. So if I were doing 4, it'll be 4 factorial for the problem that I just did, over 2 factorial, because 2 is k, 4 minus 2 factorial. So this is the heads and tails. So we're flipping the coin 4 times, getting 2 heads. So there's a 2 there, and 4 minus 2 there. So if I write it out, 4 factorial, we usually actually write it in reverse. We go 4 times 3 times 2 times 1, 2 times 1 for 2 factorial there. This is also 2 factorial, so that's 2 times 1. These simplify, and you end up with 12 over 2, or 6. So that's definitely a lot easier than drawing out sample trees. So you can also do this on your calculator. So let's say we're still using the same example, n is 4 and k is 2. You want to press n, so you put that number first. So I'm going to press 4, and then I press math, which is right there under the green button, and I scroll over to PRB, and then I scroll down to NCR and press enter, and then put K and press enter. And so what that shows me is I also get 6 here. So this is a nice, easy way to do the number of combinations. Okay, so the probability of figuring out K successes, we could already kind of figure this out. And if I get K successes, that means a probability of success to the kth power. And then whatever's left is the failures, right? And then this tells me how many different ways I can do this thing right here. So let's revisit our speckled M&M example. What's the probability we'll find 2 speckled M&Ms in the first 5 candy? Remember, 30% are speckled. Well, we know P is 0.30, Q is 1 minus P, or 0.70, N is going to be 5 because we're doing 5 candies and we want 2 successes. Always remember to revisit the 10% condition. We expect that there are more than 50 candies because remember, this should not be more than 10% of the population. So we expect that there are more than 50 candies in the M&M bag. So that's good enough, which means actually you wouldn't want to do this with a fun size bag because the probabilities would change. So the probability of 2 successes in 5 trials is 5 choose 2 0.3 squared times 0.7 cubed. See how these two exponents add up to the 5. And if I go ahead and punch all that into my calculator, I will get 0.3087. But as you well know, guess what? There's a shortcut to do this in the calculator, so you don't even have to do the combination in this setup. So to do that, it's called Binomial PDF, probability distribution function. And that has n first, p second, and x last. So here's the example. We're doing 5 candies. 2 are going to be speckled. Probability is 0.3. So the first thing I do is I hit second distribution, just like I did on the others. And you scroll up or down, whatever's easier, to Binomial PDF and press enter. Then you press n, in this case 5, comma 0.3, comma 2. So it's npx. Press enter. Whoops. And let me go ahead, press enter. And basically it will give you your number. So here it is again. Go to Binomial PDF and then press 5, comma 0.3, comma 2. Enter. And I got the same answer as I did before. All right, let's go ahead and keep on with this speckled M&M problem. What is the probability we'll find up to 2 speckled M&Ms in the first 5 candies? So it's still the same probabilities here. N is still 5 and K is 2. But now I'm doing probability of 0, 1, or 2 successes in 5 trials because we said up to 2 speckled M&Ms. So I could do all this, and if I calculate it out, I'll get 0.83692. And yes, there is a shortcut on your calculator, so you don't have to even do each of these individually. There's something called the Binomial CDF, Cumulative Distribution Function. Cumulative, think of like totaling up. So we do the same thing. We're going to press second distribution, and then we're going to scroll down to Binomial CDF and press enter. Then we'll do our n, comma, in this case 5, comma 0.3, comma 2, enter. And that will give you the same value we did by calculating each one of those individual probabilities that I just showed you, cumulative, in the calculator.